maybe the concept, but not necessarily that big of a calculus. This is more big idea kind of thing, okay?
Oh, that's
So
bad.
I is gonna be in what units?
I feel like my big ideas are complicated and stupid.
Kilogram meters squared.
How about kilogram meter squared, because it's MR squared, it's its base idea, right? So omega is in,
What is in radians per second?
radians per
Second.
second.
They're both squared.
Do you worry about the radians squared?
Not really.
Nope, not
No,
really.
because that's a dimensionless number, so you get kilograms meters squared over,
Second squared.
which is the same thing as KT, which is 1/2 mv squared, which is kilograms meters squared over
Second squared.
second squared. Yay for units. Let me see.
So are Newton's kilograms meters per second squared?
No, of course not.
That'd be ludicrous.
That'd be insane.
You know, let me explain the irony of what that just said. Why, when your timing was exquisite. Because I was just thinking to myself, look at how far your knowledge of physics has grown since the first day that you walked in. If I tried to do this with all of you the very first day you walked in, you'd be going, and now I was literally thinking, wow, these kids have made such a journey.
I mean, we
I
have.
was feeling so good about me as a teacher. What does Colin do? What does Newton do?
Doing homework over the past month, I've had to look that up
I was literally just going to brag about how much and how proud I am all of you. And
I really,
Bergen's
I
very
really feel
proud
like
of
this
everyone
really
except
sums up
Colin.
what our journey has been, though.
Can you answer the question?
What's that big sign hanging behind you say?
Dimensional analysis, day one.
I missed that day.
You know how many times we've talked about F equals zero?
No, I know that.
Do the math. Do the dimensional analysis, just real quick, in your head.
So F is an unknown. Oh. That would have been.
That's on me. I should have taught you that. That's on me. I will own that gap in the physical knowledge. Okay?
Oh man,
Oh,
he
I'm
even
gonna-
put that gap up and put lights around it.
Yeah, maybe so. Maybe like Christmas, I can put lights. No.
Alright, so I was right.
Actually, I think the rest of us made the journey. I think just Colin got left behind.
No, I think our journey is just
He's
like the
still
stock market.
recovering
It's
from
ups
this
and
that
downs.
first day.
Yeah.
Man.
Colin is the kid jumping up in the back with his hand raised.
I'm here. Guys, look, I made it.
You take a planet
Where are
and
we?
you shrink it. What's going to happen to the gravitational force measured in
It's so your radius is gonna get smaller.
but the mass of the planet is going to stay constant.
Is your location relative to the planet the same, or are you like still on
You're
the
still
surface?
standing out here on a shrinking planet.
Oh, okay. So
Well, one of them's
Hold on.
squared or something. It's like one grows faster than the other. Because radius squared.
Also, your proximity to everything.
Okay, what creates your, there's two things that you can set equal in terms of gravitational
Mass of
force,
it, yeah.
right? So this would be the mass of, I don't know, let's say Colin times G, because I so want to do this to you right now. And that's going to equal big G times the mass of Colin times the mass of the Earth squared.
Massive
So
Colin.
what's going to happen to Colin?
He gets cut out of
He
existence.
drops out.
oh,
What does little g equal?
9.8.
I would hate. Gravitational.
How about big G mass of the Earth over
R squared.
R squared?
Sorry, we're so used
so
to
if
just
mass of the Earth
muscle
stays
memory.
constant.
This man is
You want breakfast from Chick-fil-A?
hopeless.
Yes.
More than life itself.
I'm gonna go pick it up right at the beginning of the second block. I'm ordering it right now.
What do you recommend?
I like the breakfast
Bring
burrito
some right
with
here.
the chicken strips inside.
I
Delicious.
too will vouch for the breakfast
Justin likes
burrito.
the burrito with sausage.
You're not a part of the
Jesse's
club.
getting the burrito with chicken.
Let's do the burrito with sausage.
Yeah,
Okay.
good choice.
Do you want the meal so it comes with little tater tots?
Cohen, stop
And a
third
drink?
partying the
No,
conversation.
Just
Yeah,
a
just-
burrito.
That's everywhere I go.
I might not be here. I gotta go
I bet
read
you're
to
fine.
first graders over at Cray Woodman, like 9:15. So
Okay.
I'll catch you
Okay.
when I get back.
So get him a Coke or something so he has
Do
caffeine.
not talk to me.
Okay, that's what he
Not
literally
talking.
said. He said,
Oh.
not the hash browns, just the drink. And it's a Dr. Pepper, not a Coke.
A Dr. Pepper over Coke is wild.
No,
That
it
was
isn't.
bad.
No,
That
Dr.
was
Pepper is
wild
way
is
better than
that I've
Coke. I'm
taught a
not
kid
gonna
for
lie.
18 weeks and he goes, what units is force major? That's what's wild.
No.
I knew that.
Are
I
you
know.
joking?
No.
The
Literally.
dimensional, like, I know it's Newtons, but
Well, and he's a Denver Broncos fan.
I
I will not.
So listen.
Hey, don't disrespect our
him,
kind.
Yeah.
Like him, he just wanted to get your hopes up and then crush your dreams
Oh,
right here at
this
the
is
end.
what I was telling the kids. Ironically, we were doing this phenomenal review, and I was just going to tell them like how proud of them I was for their knowledge that they've gained.
Yeah.
And he drops,
Newtons
is
is
force
in kilograms
meters per second squared? And it's just like my dreams were just crushed. I mean, like you ripped the soul out of
You
my
can't
body.
save every kid, Berg. Some of us just get left behind.
No child.
No, he's
left
the one
behind.
that takes the
No
dream.
child.
That
But
was
has no
stupid.
remembrance of the entire dream.
Yeah.
Like when you're driving, you're like, wow, how did I end up here? I don't even remember making it home.
Yeah,
That kid.
Yeah, exactly.
Yeah. Yeah.
I mean,
I suddenly feel way better that he's the captain of their Scholars Bowl team.
you know what? If we're gonna be honest, I bet you he goes to practice, so I feel more comfortable him being the
Hey,
captain of ours.
excuse
Owen.
me.
Ooh. Ooh.
It's been hard, okay?
Don't
I'll
throw
be today.
stones. Hey,
I
hey.
will say Cohen skipped Scholars Bowl practice because of your class, but you know what?
Yeah.
I know.
Yeah, Bird.
don't throw stones in a nerd
And
house.
wait, but
okay?
we still don't do your homework. What do you
Any stuff? Do I have the lab Friday? No.
Do you want it? I will staple and turn it in right now. Literally, I will stand up and do
The
that.
question was, do I have your lab?
Not yet.
Did he have your lab?
I think it'd be a no. Would
Quick,
rather-
someone do
Hey,
something
pan
over
the camera
time.
to him.
Okay. Anyway, so back to our story on the shrinking planet. Much like my hopes for your grades tomorrow. So, God. As you shrink the radius, what's going to happen to the value of little g?
Gonna increase.
It's going to increase linearly or inversely.
Inversely.
Inversely,
With the
because
square of
R squared.
r squared. So, if this is the value of
Inversely
little
squared.
g as it is right now, as 9.8 meters per second squared, and this is the radius of the Earth, then as that radius gets smaller,
Oh, is the
radius
mass
gets smaller,
constant?
the value of little g would go bigger, right?
Yeah.
Right? What's going to happen to your mass on a shrinking planet?
Does not matter.
Nothing.
It's going to stay the
You
same,
literally
right?
cancel out your
Right.
units right there with you, with your mass as well.
No, I meant like mass of
for
the
weight. You're
like
lying
as
on
the
the-
planet shrinks, it's not like losing mass. It's just becoming.
More dense.
Yeah.
Your
And
line,
it's
your
not
line
like
on the
if-
graph is
I was like, I
backwards.
didn't. I kind of
It's
account
not
for
like
the
it should be-
changing mass of the.
Yeah.
If you
So yeah, it
if
should
you
go
like,
like that.
change the mass of the
There we
planet,
go.
it's like your
Okay.
mass just like
Cool with that. Speaking of
someone
centripetal motion,
explodes and college
Ooh.
vaporizes.
what does centripetal acceleration equal?
B
Basic
squared over
way,
R.
easiest way,
B squared over R.
b squared over r.
That's why.
Good job, guys.
Now,
Look
if
up
you have a
Totally
spinning
got it.
surface, if you have a flat spinning
Oh, yeah.
surface, if you have a flat spinning surface,
Flat spin.
Yeah.
what's creating the centripetal force?
Dude,
Gravity?
Inertia?
Force.
Inertia is not a force.
Inertia is a property of matter. Come
I
on.
know that.
Look,
It's centripetal force.
but what's creating the centripetal force?
torque.
It's either a string, gravity,
Friction.
or friction.
Friction.
Friction, string.
Okay, yeah, friction. Yeah.
Friction, string, gravity.
Depending on how you set it up, friction. Or
Friction! You're on a flat spinning surface?
What if but
No.
what if you got a pole and a string?
No.
Then it would be a string.
We're saying the distance
No.
spinning, we're just saying
Yeah.
Now, does mu equal force friction over force normal?
Yes.
Yes.
But your force friction is creating your
Force centripetal.
centripetal force. On a flat surface, force normal equals
This has been
we'll
an
write that as mass times centripetal acceleration over mg.
Berg, maybe we should make the written test Wednesday.
No.
Then we have one big
Wait,
lab.
so wait,
No,
so
no, no,
tomorrow,
we switched
what
the
are we doing
lab
tomorrow?
and over to
I mean,
the
shoot,
Oh yeah, we can do that.
never
yeah.
mind,
Yeah. That'd
I'm
be
gonna
bad,
cry.
especially for like.
What are we doing tomorrow? I don't know. Maybe what we're reviewing for?
I hope not.
To be honest, I thought it was one.
Can we opt out? I like my
I
grade.
thought of the test occurring in a vacuum, you know?
Okay.
Yeah, fair enough.
I'm not
So
sure.
if you have a stack of 10 quarters and a single quarter, and they're the same distance from the center, which one will undergo the greater centripetal acceleration? They're the same. Which one will require more force?
Stack of 10.
Big.
Stack of
Much
10
like,
quarters.
much like how we started this with Colin snowboarding on the horizontal, right?
Mm.
Oh.
It's like Calvin's dad from Calvin and Offset.
Where are we going with this?
Like with the record, like he
Oh,
demonstrates that to Calvin.
Yeah. Actually, I know exactly what Pele talking about. How it makes the
Okay.
same rotation.
Now, what else can centripetal acceleration
And then
equal?
Calvin says,
Uh,
schizophrenic.
No, that's
It was something weird.
4
4 pi squared r over t squared.
Why? What do the units have to work out to, Colin?
right there.
Do it! Wrong time to look away.
What's your radius gonna be?
Meters per second.
There it is.
And if I multiply that by mass, I get
Kilograms, meters.
otherwise known as.
Amen.
Yes, you did it.
Hallelujah.
Literally the lecture from day one. Again.
If you have 2 quarters on a spinning object, which one will undergo the greater centripetal acceleration?
The one with
The one
the greater
further out.
radius.
Go to the
The
inside.
same? The one on the inside or the one on the outside?
The one with the one with the greater
The
radius.
outside. The outside.
Will they both have the same period going around?
Yes.
Yeah.
Same period, bigger
So if
radius.
you have a bigger
Equal bigger
radius,
acceleration.
Wait, Gapchon, think about this. You put the 2 quarters on the thing and you spin it. Which one goes up first?
Outside of
Yeah,
my bad, again, I should have done that demo for you.
What was this?
like 3
I
times.
just retook the test as well, like literally last week. So
What was the scenario where the centripetal acceleration was equal? You did it like a little bit ago, I think.
No, when they're
That's
at
if
the
you
same
had the
radius. Same
and you
radius.
had 2 different masses.
Oh, okay. Yeah.
That's when the mass don't matter.
So this one has a bigger radius, but is the period gonna be the same for both of them?
Yes.
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 yes, I said yes.
C.
Okay.
Yes.
Period equals 1 over frequency. So as the frequency increases, what happens to the value of t?
Decreases.
These are inverses of each other. So could I also write this as 4 pi squared r f squared?
Yeah.
Yep.
Sure.
That does seem legal.
Would the
That-
units still be the same?
Yeah, because that's
Yeah.
yeah.
Because if they're not,
We go to
Yeah.
physics jail.
we have
Bad things.
problem, because that's meters, frequency is in
1/seconds squared.
squared,
Or hertz.
okay? Let's say that you have a planet orbiting a sun.
Hertz is just 1/seconds.
Yeah.
What do you know about the velocity when the radius becomes smaller?
Becomes
It's greater.
lesser.
What?
Velocity
When the radius is smaller, the velocity.
it's going the same distance in in the
increase the radius, you increase the
it's going the
velocity.
same it's going a lesser distance
In the
in-
same amount
in
of
the same
time.
time.
So it's going slower.
No, because Kepler's second law that
Oh,
says
oh,
that
what?
it sweeps out area, equal areas in equal times.
Oh, I didn't know.
Oh,
we
it's
were
a star.
playing.
Oh.
I thought you were talking about a
Oh,
record.
that's
No, no,
yeah.
no.
No,
we
no, no,
we
We have
all
a
thought you were
star
doing the record.
with an
It's
elliptic.
like
No,
it's
we
a pretty
didn't.
elliptical record.
Oh, I
So
did.
it's faster right there. It's not.
So what was the
Now,
question?
does L equal I omega?
Yes.
Mm-hmm.
Does V equal R omega?
Yes.
Mm-hmm. Yep.
Victor equals wide receiver. Yes.
Yeah.
Yes.
Right? So if I solve for omega, I get
V over
V over
R.
R.
V over R. Now, a
Equals
planet is a point mass. True?
So M
Yep.
R.
Mr squared times
B over R,
V over R.
which
You
is
get M V.
MRV.
MRV.
Or
So,
room.
does the mass remain constant?
Yeah.
Yes.
Rocket volume.
It better.
Wait. So is
Ooh, so an L has to be
same.
The same.
conserved.
Yeah.
So when your
So
radius
therefore, the
decreases,
radius
your
gets
velocity
smaller.
increases.
Velocity increases.
Velocity has to get bigger.
Yeah,
So you
the closer to the
prove
star, the faster you go.
Kepler's second law
Is that-
of motion by the law of conservation
Yeah,
of
yeah.
angular momentum.
So-
Well, also,
We'll have
like,
to write that
like,
out on the test.
could you
Huh?
think?
We'll have to write that out on the test.
What did you- I didn't hear what you said.
We'll have to write that out like on a test, like proofs.
No.
Okay.
I would say prove Kepler's second law by the law of conservation of angular momentum, but that's all you'd have to do. I mean, it would be the simple, if you, believe me, you would, if I had to pick a proof, that would be an easy proof.
Also, that's
I
one
would
of those nice
correct
ones,
you
'cause, like,
completely.
if you just like
Okay.
imagine how planets orbit, like the closer to the star they get, the faster they go. It's like it's
Because the total energy in the system has to remain constant, right? Which is kinetic plus potential energy. So,
I comment
since
on
that
this.
energy has to be conserved, when it gets closer, what happens to your kinetic energy?
Becomes greater because
It becomes bigger because you have less
potential.
potential energy because you're closer to the star. Okay?
So angular momentum is also MRV.
peak
So could you do like momentum
Yeah.
times R to get angular momentum or not? Because
Could you
momentum
do
is
what?
MV.
Well, let's look at this.
Energy equals
Okay.
MRV.
Let's say you have a sun
Multiple rocket
and you have a
volume.
planet going around, right? So that rotational kinetic energy would be 1/2 I omega squared.
but yeah.
True?
Yes.
True. And if, since it's a point mass, that's gonna be 1/2 I, instead of I, you can put,
MR
MR
squared.
squared.
And then V over R squared.
V squared.
V squared over R
Sorry,
squared.
So
yeah. R
And the
squared
R squared
cancel.
cancel out, and then you have
1/2 MV squared,
MV squared,
which is just kinetic energy
which
because
is KT.
they're the same. Because the only thing it's doing is
but it only
moving.
works at the point mass.
yeah.
Or thin hoop.
Or a thin hoop, yeah.
Which is-
So if you have a thin hoop orbiting
Like a halo, right?
Please make that a problem.
I still wanna find that one, I
halo
don't
ring.
have
Yes.
time, it have,
Is orbiting.
like,
the
what would
sun.
have to be the mass of the planet to get an what was your acceleration, Danny?
Mach 2.
Yeah, it was like, yeah, Mach
how
2
do you
after
Mach
1
2?
second, something
Mach
like
2
that.
from a
Yeah.
piano being lowered.
Here's
3
your extra
meters.
credit question.
3
Prove,
meters.
find the mass of the planet Danny would have to be on to have something going Mach 2 after 1 second. Okay,
Can you put like a conversion from Mach to meters per second? Because I don't.
He's on
It's like 700 something.
Yeah.
miles per hour.
That's miles per hour. Isn't it like 330 or so?
All right,
Per
so
second.
those are the big things. So I'm done. I know you guys have to go.
I'm also done living and being happy.
So
I might fly to
the there, if you haven't picked up and if you want them, there's the study guide with the answer keys, so those are back there.
So-
I can't wait to watch this video 4 times tonight.